Hello students. Hello and welcome to this video on binomial theorems and expansions. So we will solve question number 21 to 30 in this video. The link to download the PDF will be in description, as well as at the end I will show you how you can download the updated PDF copies and maintain an updated version. And the question answer website I have created for you to ask questions as well as answer them, because YouTube comments is not really a suitable place to discuss mathematics. So without further ado, let's get started. Question 21 says that if A be the sum of the odd terms and B be the sum of the even terms in the expansion x plus a to the power n, show that 4ab is equal to x plus a raised to the power 2n minus x minus a raised to the power 2n. So according to question, x plus a to the power n will be a plus b, because a is the sum of odd terms and b is the sum of even terms. From binomial theorem, we will have that x minus a to the power n is equal to a minus b. So if you raise to the power 2 of this expansion, we will have x plus a to the power 2n is equal to a square plus b square plus 2ab. And if we square this relation, we will have x minus a to the power 2n is equal to a square plus b square minus 2ab. Now we subtract this from this, and we have x plus a to the power 2n minus x minus a to the power 2n is equal to 4ab. Question 22 says that if n be a positive integer, prove that the integral part of 5 plus 2 square root of 6 to the power n is an odd integer. So we let 5 plus 2 raised to the power 6 to the power n, 5 plus 2 square root of 6 raised to the power n is equal to alpha plus beta, where alpha is a positive integer and beta is a proper fraction. Now we know that 0 is less than 5 minus 2 square root of 6 less than 1. From this calculation, we know that. So we raise this to the power n is equal to beta 1. Clearly, beta 1 will be between 0 and 1. So alpha plus beta 1, we add these two, we get the even terms here. 2 times 5 to the power n plus nc2, 5 raised to the power n minus 2 times 24 and so on, which will be an even number. So beta plus beta 1 is equal to an even number minus alpha is equal to an integer. So 0 less than beta less than 1 is what we have, and 0 less than beta 1 less than 1 is also what we have. We add both, we get 0 less than beta plus beta 1 less than 2, but beta plus beta 1 is an integer, so beta plus beta 1 is equal to 1. Now clearly alpha plus 1 is equal to an even number, so alpha is an odd number. Question 23 says that if 3 plus square root of 8 to the power n is equal to alpha plus beta, where alpha, n are positive integers and beta is a proper fraction, then prove that 1 minus beta times alpha plus beta is equal to 1. So proceeding like previous problem, we have alpha plus beta times 1 minus beta is equal to alpha plus beta times beta 1. Because beta plus beta 1, if you see, is 1 here. So 1 minus beta will be beta 1 here. So that means this is equal to 3 plus square root of 8 to the power n, because alpha plus beta from previous expression is this and beta 1 is this. So this is equal to 3 plus square root of 8 to the power n times 3 minus square root of 8 to the power n, which will be, when multiplied, 9 minus 8 to the power n, which is equal to 1. Question 24 says that find the quotient of x in the expansion of 2x minus 3 upon x to the power n. So we let the rth term contain x, then tr is equal to 9c r minus 1 2x raised to the power 10 minus r times, this should be plus 1 here also. There is a typing mistake, seems like. And then multiplied with minus 3 over x to the power r minus 1. Now let me think. So what was the expansion? Oh, 9. So this is fine. This is 10 minus r. 1 is added to 9. So we see the power of x is 10 minus r plus 1, which will be equal to 1, because we have to find the quotient of x. So R is equal to 5, and the quotient is 9C4, 2 raised to the power 5, 3 raised to the power 4, is equal to 2592 times 9C4. Question 25 is similar. We have to find the quotient of x to the power 7 in the expansion of 3x squared plus 5x raised to the power minus 1 whole raised to the power 11. So PR is, in this case, 11CR minus 1, 3x squared, 12 minus R, 5x to the power minus 1 to the power R minus 1. Since the term contains x to the power 7, 24 minus R, 2R from this, and R minus R plus 1 from this is equal to 7, so R is equal to 6, and the quotient of 11C6, 3 to the power 6, 5 to the power 5. So that is the quotient. Question 26 is similar. We have to find quotient of x to the power 9 in the expansion of 2x square minus x to the power minus 1 whole to the power 20. So in this case, TR is 20CR minus 1, 2x square 21 minus R minus x to the power minus 1 whole to the power R minus 1. Now, since the term contains x to the power n, therefore 42 minus 2R minus R plus 1 is equal to 9. So it does not give an integral value of R, therefore quotient is 0. Question 27 says we have to find the quotient of x to the power 21 in the expansion of x squared plus 3a x to the power minus 1 whole to the power 15. So TR in this case is 15CR minus 1, x squared to the power 16 minus R, 3a to the power minus 1 whole to the power R minus 1. Now, since the term contains x to the power 24, therefore 32 minus 2R minus R plus 1 is equal to 24, so R is equal to 3. And therefore quotient will be 16C2 9A squared. Question 28 is similar. We have to find quotient of x to the power 9 in the expansion of x squared minus 3x to the power minus 1 whole to the power 9. So we have to find the quotient of x to the power 9 in this expansion. TR is equal to 9CR minus 1 x squared to the power 10 minus R minus 1 upon 3x whole to the power R minus 1. Since it contains the power of x9, therefore 20 minus 2R minus R plus 1 is equal to 9, that is R is equal to 4. The quotient is 9C3 times 1 minus 1 upon 3 raised to the power 3, that is minus 28 upon 9. Question 29 says that find the quotient of x to the power minus 7 in the expansion of x minus 1 upon 3x square whole to the power 11. So in this case, our rth term is 11CR minus 1, 2x raised to the power 12 minus R minus 1 upon 6 square to the power R minus 1. Since the quotient is to be found of x to the power minus 7, therefore 12 minus R minus 2R plus 2 is equal to minus 7. That means R is equal to 7. Therefore, quotient is 11C6, 2 raised to the power 5 upon 3 to the power 6. Now, question 30 says that find the quotient of x to the power 7 in the expansion of x squared plus 1 upon bx raised to the power 11, and the quotient of x to the power minus 7 in the expansion of x minus 1 upon bx to the power 11. Also find the relation between a and b so that quotients are equal. So the second one is a bit typing mistake. This should be bx squared, I believe. The quotient of x to the power 7 in the first expansion is 11CR minus 1 x squared to the power 12 minus R 1 upon bx raised to the power R minus 1. So since the quotient is of x to the power 7, 24 minus 2R minus R plus 1 is equal to 7, R is equal to 6. So the quotient is 11C6, A raised to the power 6, B raised to the power minus 5. Now quotient of x to the power minus 7 in x minus 1 upon bx squared to the power 11, then TR is equal to 11CR minus 1 x to the power 12 minus R minus 1 upon bx squared raised to the power R minus 1. Over here also quotient is found to be for R is equal to 7. So quotient now is 11C6, A raised to the power 5, B raised to the power minus 6. Now quotients have to be equal. We see that 11C5 is equal to 11C6. This side we have A, this side we have B, that is AB is equal to 1. So that is the required condition for the quotients to be equal. And with this, we come to the end of this set of problems. Now I'll show you my website. So the website is astavoxer.org. Why is it not coming? Okay. So second, third, and fourth links are of Algebra, trigonometry, and coordinate geometry, you can download the PDF. The downloaded PDF will not have date, so you can use this date timestamp and put that into date. I cannot really put the date in the downloaded file because that will make all the existing link invalid when the date changes. So also, if you want to ask questions, click on the 8th link to come at kundika.afterwork.org. You can come here and ask questions, and you can go to Markdown Help to see how we can ask questions here. This will be in the editor help button is there. You can come to this link from there. So tags are created for you: algebra, calculus, coordinate geometry, geometry, probability, trigonometry. So use these tags to ask questions related to mathematics. Registration is very simple. Username, email, you will be sent a confirmation email. Click that link. Your login email will be confirmed. For creating login, you put an email with which you are registered. You'll be sent a code, put that in, you'll be logged in. You can ask questions here. And if you look at Markdown help, then you will see that how we can type math questions. I will expand this actually. So if you see MathX2 support, LaTeX math is supported. So I'll put more examples on how you can type math here, but it is LaTeX math. So if you don't know, don't worry, I'll put extra information on how you can ask math questions. So with this, we come to the end of this set of problems, and I hope that you are finding this playlist useful and informative. So I will take my leave here, and we will meet tomorrow with 10 more problems. And till then, I'll say bye to you. So keep learning, have a nice day, and enjoy.